Okay, we're going to start. Right, so we are starting 1G today, which is power functions. Now, we should all know that a power function just means we've got the base and then a power. Okay, that's all that means. The power can be any rational number whatsoever, it doesn't matter. Then we've got the two different types. There's an increasing and there could be decreasing functions. Now we know, and I'm going to draw this one here, if we've got a straight line, this is my axis, and I've got a straight line, as x increases, okay, so x increases, that's what's saying x2, the next value of x is, as the next value of x, sorry, is bigger than the previous value. So as x increases, what's happening? It's getting bigger and bigger. This means that it is a strictly increasing function. And if we go the other way, as x increases and y decreases, the function decreases, then we have a strictly decreasing function. So we know this, it's not something that's said, but we definitely know this. Any questions about that one? That's what's saying in those two statements above. Okay, so let me just clear this. Now this, and I'm pretty sure we went through positive and odd and even functions prior. I think it was earlier on in chapter 1 when we did it over the break, but just to give you a rundown, x to the power of 4, okay, x to the power of 4, that is an even function there. Let's get my annotation happening, there we go. Okay, it is positive, we can see it's positive, okay, but that is an even function. But I'm not going to go through all these. Have a quick look, all right, and just ask me any questions about them that you need. It doesn't have to be today. So we've got a cubic function, we've got an even function, even though it's 1 on x squared here. Okay, that's 1 divided by x squared. It's still an even function. It's negative because there's a negative power, but it's an even function. This is an odd function. Number 3 is an odd. It's negative power, so it's an odd negative. Okay, here we've got an even function. It's even. There's a number 2 there. We can see that. Here we've got an odd function. There's a number 3 there. We can see that. Okay, so there's the difference between our odd and even functions. There's no questions, I'm going to move on. Hey, we've got everyone. Beautiful. Okay, so let's do an example. Better clear that, not save it. Okay. Example 12 says, for the function f with the rule f of x equals 1 on x divided by 5, state the maximal domain in the corresponding range. Well, the only time this will not exist is when this denominator equals 0. Okay, and that will equal 0 when x equals 0. So we've got our maximal domain of all rules except 0. And really, if we sketch that, and we have to do a sketch, and I've said to use your calculator, but I'll quickly draw it up here. If we sketch this, can anyone tell me what type of graph that is? No? Well, that is just a hyperbola. Oops, bad graph. It has an asymptote at x equals 0, and it has an asymptote at y equals 0. And therefore, that's why our range is rules / 0. But we could have rearranged this. Let's say that was y. We could have gone x to the power of 5 equals 1 divided by y. And we can see straight away that y cannot equal 0. Okay, so there was our asymptote as well. But that's all it is. Okay, that x to the power 5, 1 divided by x to the power 5, sorry, is just a rectangular hyperbola. If you're not sure and you haven't got your calculator, you can put x equals to 1 and you get y is 1. You put x equals 2 and you get y equals the half. X equals 3 and y is the third, and you swap them around. Or what, sorry, not a 2 to the power 1/8. 1/8. Okay, when x equals 2, so 2 to the power 5 is 8. Okay, so you can do it like that and you can get an idea of how the graph looks. Any questions so far? Okay, we're going to go now back to part B, part 1. Evaluate each of the following, f of 2. And it probably would have been easier if I did this and then graph it, but it doesn't matter. So f of 2 equals 1 divided by 2 to the power 5. 1 divided by 4, 8, 6, 32. Not 8, like I said before, 1 divided by 32. F of negative 2 will be 1 divided by negative 2 to the power of 5, which is negative 1 divided by 32. F to the half will equal 1 divided by a half to the power of 5. Now, this is just going to be 2 to the power of 5, which means it's 32. And f to the negative a half equals 1 divided by negative a half to the power of 5, which is just going to be negative 2 to the power of 5, which means it's negative 32. And we can get our graph from there. Any questions here? Okay, I'll just wait a minute while you guys are copying that down. I'm assuming I have all these people. Let me just see. Okay, Jaden, you still haven't signed up for Cambridge. I am going to set the test. I've been telling you guys that the test was going to be this week. I'm going to set the test for you guys tomorrow. Okay, tomorrow you guys finish early at lunchtime on a Tuesday. So I will set it, and if anyone says that they've got to, got to go to work or anything, that's fine. Let me know. Please speak up now because everyone's on here. I will set the test tomorrow at 2 to 4. How does that sound? And then we'll do chapter 11 later on in the week, probably on Friday. I'll set it Friday. So tomorrow 2 to 4 is all good. No one's sending me a chat and no one's saying anything. That's chapter 10. So Jaden, sorry?
Is this 2 to 4 o'clock or period
2 to
2
4?
to 4?
No, 2 to 4 o'clock. Yep. Right, 2 to 4. It's not going to take you 2 hours, but you can do it any time between them.
Right.
Right. It's only a quiz. It's not even a test. I think there's 16 multiple choice questions. Okay. So think what it's going to take you. Don't give yourself 5 minutes because it's going to take you longer than 5 minutes. Maybe start it at 2:30 and you'll have the hour and a half. You won't need the hour and a half, but you'll have the hour and a half. So, but Jaden, you need to come on. James, you need to come onto the Cambridge as well. Long, you need to come onto the Cambridge. And Marco. So I will set it today for tomorrow. So if you guys are not on by the end, or let's say, by the end of the day, then you probably won't be able to access this test.
What's the class key for the Cambridge?
I sent it to you guys.
To access it.
Yeah, I emailed you guys, so just have a look. If you can't find it, just let me know. I don't want to get in there now. But remember, and I said, if you've already joined a Cambridge before, whether it was year 11 or this year in year 12, you don't need the reactivation key because you don't care about the book. But if you've never joined it, then unfortunately you're going to have to get an activation key. And if you've got an old book, all you need is to pay the $19.95. Okay, this is the only way we can do assessments. Okay, clear that. Let's move on. And since I've all got you now and I'm talking to you, don't forget, please, chapter 11, exercise A, all the way through to J. You can even send me the chapter review if you want, but A to J, all those questions so that I can mark you off that you've done work. Even though I know you've done work, I've still got to see them. Okay, next example. Excuse me. Let f such that reals/0, remember reals/0, that is the domain. That is the codomain only, it's not the range. F of x equals x to the power of -1, that is, if it's very faint, but that is f of x equals x to the power of -1. And g such that reals/0, again our domain, to our codomain, where g of x equals x to the power of -3. Find the values of x for which they are equal. Well, if they're equal, we're going to put them equal to each other. So instead of writing it as x to the power of -1, I've written it as 1 divided by x. And instead of x to the power of -3, I've written it as 1 divided by x to the 3, and I've equated them. And therefore, when I simplify this, it becomes x squared equals 1. Now, for those of you, I can just times by x cubed, so I'll get that. And then it simplifies to x squared. And then, of course, when I square root, I get x equals 1 and x equals -1. Any questions with part A? And it says, sketch the graphs of y equals f of x and y equals g of x on the one set of axes. So I've got my calculator out and I've sketched them. They do cross at 1, 1 and -1, -1. You can see they are exactly the same graphs because we've got a 1 on x, a rectangular hyperbola, and we've got a 1 over x cubed. Same thing. It's not an x cubed function. Okay, it is 1 divided by x cubed. They are just rectangular hyperbolas. They both cross 1, 1, sorry, 1, 1 and -1, -1. Okay, the x cubed you can see is steeper. That's the red line, so it's steeper here and closer to the x-axis there, and the same thing here. Steeper, closer to the x-axis. So the bigger the number, the closer it is to the x-axis and steeper it becomes, but that's about the difference. If you're only graphing only of these on an axis, no one's going to see that difference. Any questions there? Okay, I'll clear it. Let's move to example 14, which is our last one for today. It says, find the inverse of each of the following functions, students to complete. Okay, so we've got to find this inverse. Now, remember, we've got f of x equals x to the power of 4 here. We can't just say swap x and y because there's no y. So we're going to say let f of x equals the y, which equals x to the power of 4, swap x and y. You can see I'm writing it down all the time, and that's what you need to do. So you get x equals y to the power of 4, and therefore y is the 4th root. You can write it like this, or you can write it as x to the power of 1/4. It doesn't really matter. Therefore, f to the -1 of x, the inverse, equals x to the power of 1/4. I really like to write it as the 4th root, but I'll write it as x to the power of 1/4. Should always work out the domain and range here. Okay, should always do that. So we know our domain between -infinity and 0, and x to the power of 4, in case you have forgotten, looks like this. It is a U, a parabola, but flattened down the bottom and looks like that. But we don't want the positive part of it. We only want between -infinity and 0. So this part is out. Okay. I should have erased it, not done that. Erases the whole thing, that's why. Okay, so let me draw it again. Okay, so that's the part that we actually want. So even though that's the domain of the function, the range of the function is from 0 inclusive, because 0 is inclusive there, to infinity. So when I write the inverse, f to the -1 of x, such that, okay, the domain of this function, the inverse function, is the range of the original function. So I've got 0 to infinity to the codomain, it's always reals, of f to the -1 of x equals x to the power of a quarter. Any questions there? Okay, let's do the next one. Let y equals, sorry, let f of x, I like to call my f of x first. Let f of x equals y, which equals 64 x to the power of 6. Swap x and y, so we get x equals 64 y to the power of 6. Now here I need to divide by 64 first, so y to the power of 6 equals x over 64, and then y equals the 6th root of x divided by 64. Okay, so I'm actually going to, 64, is that a 2? 2, 4, 4 2s are 8, 16, 32, 64, yes. So this becomes, I'll write it as the inverse now. The inverse of x equals x to the power of 1/6 all divided by 2. Now you could write it as a half x to the power of 1/6. Okay, that's probably easy. You can leave it as a half the 6th root of x. I sort of like it like this, but it doesn't matter. Okay, any questions on that one? Okay, and I'll let you guys work out your domain and range. You should be able to graph this one for me. Okay, between 1 and infinity. You should know how that looks like anyway, so you should be able to give me that range pretty quick, and then for this graph, and then you just swap them over. All right, any questions? Thanks, Pino, for sending that to everyone. I'm pretty sure you're right. I can have a look now. Actually, I'll have a look now. So just give us a second. I'm getting to the Cambridge. It is SPUN 252. Thank you, Pino. Excellent. So Pino is correct. SPUN 252 is the class key for the Cambridge. Okay. You guys got any questions that you'd like me to do on anything?
Is there another way to figure out the range of the original function? Is it that you substitute the values of the main in?
Well, either you substitute values in, or you've got to know how that graph looks like.
Right, okay.
Okay,
So for example, that for part B,
the
domain is 1 to infinity.
Yes.
If you sub that into f of x, we get 64 and infinity. Would that be your range?
Correct.
Right, easy. Thank you.
But not inclusive, right? Because C1 is not inclusive, right?
Yeah.
So yes, that would be your range. It's just a
Right.
positive. Really, it's a parabola that starts at, when 8x equals 1, it starts at y equals to 64 and just goes up, right? That's what it is, just a parabola like that. And that's what it's going to end up being. But you are correct, it starts at y equals 64. Not inclusive, of course, because remember, we always got to check these brackets here. Okay, not inclusive for both the 1 and, of course, the infinity. Okay. Well, I might as well, no, I won't. All right, you guys can finish it off. All right, any questions? Any other questions? Okay, so please don't forget, if everyone signs up for Cambridge early, I will set the test today. but the latest I'll set it is either tonight or early tomorrow morning. So like 8:30, 9 o'clock. Okay. And if you miss out on it, that's it. You miss out on it. I can't keep waiting, because then, as I said Friday, I want to set chapter 11 test or quiz. And they will both be going on to Simon for you guys. All right. If you've got no questions,